Section 9.2.39, a study asked respondents, if ever married, how old were you when you first married? The results are summarized in the technology excerpt that follows. Completes part A through D below. So here is the one sample T, which is age wed. The variable is the age wed. The sample size is 27,210. The mean is 20.990. Standard deviation is 4.723. The standard error mean is 0.029. And the 95% confidence interval goes from 20.934 to 21.046. Now we want to use the summary here to determine the point estimate of the population mean and margin of error for the confidence interval. Okay, so recall that what we want to do first is we want to be able to find the mean. Well, we already are given the mean. The sample mean is given here. So there is the sample mean. So the sample mean is equal to 20.990. Okay, and the next thing we want to do is we want to be able to find the margin of error. So remember that if you had the upper bound, well, that was equal to the point estimate plus the margin of error. Okay, and just going to move this over just a tiny bit here. And we know that the lower bound is equal to the point estimate minus the margin of error. Okay, so if we wanted to write this in abbreviation, well, the upper bound is equal to the mean plus the margin of error, and the lower bound is equal to the point estimate minus the margin of error. Okay, so we're just going to use the information that's given. Well, the upper bound here is 21.046. So we have 21.046. We know what our mean is, which is 20.990 plus the margin of error. So if we want to solve for the margin of error, we're going to subtract 20.990 to both sides. So isolating the margin of error on the right side and subtracting, we get 0.056 for the margin of error. Now let's just verify that the lower bound is going to give us the same thing. So the lower bound we know is 20.934. We know that our point estimate is 20.990, and we're going to subtract the margin of error. So when we subtract 20.990 minus 20.990, then we get negative E over here, and we get negative 0.056, and then dividing both sides by -1, then we get 0.056, which is the margin of error. So either or could have gotten you the margin of error to be 0.056. Okay, next. What we want to be able to do now is we want to be able to interpret the confidence interval. So using the confidence interval up here, knowing it's 95%, well, we can say that one can be 95% confident that the mean age of people when first married is between 20.94 and 21.046 years. Okay, next in part C, it says verify the results by computing a 95% confidence interval with the information provided. So basically what it's saying here is we're going to go ahead and use the fact that the mean is 20.990. We know that the sample standard deviation up here is 4.723. We know that the sample size n is 27,210. And we want to find the critical value according to the 95%. So if we want to find the critical value, alpha is 100% minus 95%, which is equal to 5%, which is equal to 0.05. So we're looking for t 0.05 divided by 2. So the area in the right tail is 0.025. And we also need to know what the degrees of freedom are. And the degrees of freedom is taking the value of the sample size and subtracting 1. Well, the sample size is 27,210, and we're going to subtract 1, which is going to be 27,209. Okay, now we're not going to have that on the table, so we're going to have to use either the TI-84 or Statcrunch. So we're going to use INVT with the degrees of freedom, the area is 1 minus 0.025, and the degrees of freedom is going to be 27,209. Okay, so let's go ahead and find that using our calculator. So we're going to use second distribution, and we're going to go to INVT. We're going to take 1 and subtract 0.025, which is already in there. And the degrees of freedom is going to be 27,209. And then hit enter for it to paste. And then we're going to hit enter. Okay, so let's go ahead and copy that. So if we round that to 3 decimal places, we're going to get 1.960. Okay, so it's 1.960. Okay, now if we wanted to use Statcrunch, then we would go to Stat Calculators, and then we'll go to T. Okay, and we want the area to the right if we want to use just this is greater than or equal to, if we want to use the area of 0.025. So if we use 0.025 and then put in the degrees of freedom of 27,209 and then compute, then we're going to get the same. Now if we had the less than, then it's going to be 0.975, and it's still going to give us the same critical t value. Okay, so now that we have that, now we can go ahead and find our lower bound and upper bound. So the lower bound is going to equal the mean, which is 20.990 minus the critical value of 1.960 times the standard deviation of 4.723 divided by the square root of 27,210. And so therefore the lower bound is approximately 20.934. And if we want to find the upper bound, then that's 20.990 plus 1.960 times 4.723 divided by the square root of 27,210. And so therefore we get the upper bound to be 21.046. So that verifies our confidence interval here, 20.934 and 21.046. Okay, next question, it says, why is the margin of error so small? Or, excuse me, why is the margin of error for this confidence interval so small? Well, the reason why the margin of error is so small is because take a look at the sample size. The sample size is 27,210. That's quite large than what we've actually dealt with. So therefore, the sample size used is very large.